Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay. Before we start our lesson, let's pray. Pray begin. Amin. Right. How are you guys?
Fine.
Good. Okay. If you don't have any problem with the connection, can you turn on the camera so I can see your face? All right. So how was your holiday? Did you cut the cow
Yes, sir.
or lamb?
Cow.
Always eating meat, right? Every day?
No. I store it.
Good. So it was a long holiday, yeah? 3 days from Friday, Saturday, and Sunday. And so this week, again, we are going to start study. Hopefully, you didn't forget what you have learned from last week. What you learned from last week in chemistry? You learned about what?
Lab safety. Safety.
Lab safety.
Right? You learned about the safety role last week. And some introduction to laboratory, isn't it? Good. So today we are going to continue our lesson. Still, we are talking about the laboratory things, and then after that we move on with another topic. But as usual, before we start our lesson, let's fill in the attendance. You know already the link. If you have saved the link, you can fill in that link, and also I'm going to put it again in the chatting room so everybody can fill the link. Okay, that's the link for the attendance. Please, everybody, I give you 1 minute to fill the link. Is there anyone absent today from the morning? No? Everyone is here? Good. If everyone is here, so it must be, I think it's now 19 students in your class, not 20, right? I heard that one of your friend is resigned from the school. Is that true?
Yes, sir.
Yes, so 19 students. 19 students, and now we have 15 students, so we still have 4 more students. Okay, 16 now, 3 more students are still outside the classroom. Okay, no problem. Let's continue. Okay, while you are filling the attendance, let me share my screen so we can see what we are going to see today. All right. So this is chemistry lesson 8, video conference, August 4th, 2020. And what we're going to see today, our topic is about still introduction to laboratory. Okay, after last week, we discussed a little bit about the safety rule and some of the important thing in what entering the lab, for example, about your dress, about the rules that you have to follow when you are entering the labs. And also we're talking about the labeling, some labeling in chemicals. And we're talking about the disposing the waste of the experiment. Those are the things that are very important for us. Safety, yeah, safety is coming first. I told you last lesson. Okay, today we are going to continue with the work safety in the laboratory. Still, we are going to learning about this one, work safety in the laboratory. So what we are going to talk about today is about lab equipment and the use, okay? By the way, the one that I'm going to explain here, only some of them, not all of them. So you can go to your books or any sources from the internet to find out what is another lab equipment and what is the usage of that equipment or the function of that equipment. So I'm going to mention only some of them, which is common in our experiment. But this is not only this. Maybe in the question later on, there will be coming another type of equipment. So you can go to your books or any other sources to look at what are those any other equipment that can be in the lab, okay? So let me start with the first one here. The most common glassware in the lab is called as a beaker. So the beaker is like this, okay? It's like a cylinder things. We have variety of beaker from the smaller size and the bigger size. We have, for example, 5 milliliter of beaker, and we have also 500 milliliter of beaker. So from the smaller to the bigger beaker we have. What is the function of this beaker? The function of this beaker is to running the reaction, mixing chemical and heating chemicals. So mostly you're going to mix the chemical here, or you're going to take the chemical, which is liquid generally, to this beaker. And if you need to mix it, and also if you need to heating it with the fire, so you need a beaker. Okay, so those are the beaker. So we have from the smaller beaker till the bigger beaker. Okay, the second one, we have a conical safe glassware like this, and we have a hole here, a canal here. We call this one as a filter flask. Flask is a kind of glassware, yeah, flask. So it is filter flask. So from the name, we understood that this flask is used for filtering. But this filtering is not a normal filtering. This filtering is using the vacuum filtration. So this hole here, or this canal here, will be connected to the vacuum machine. I think you know the vacuum, right? Maybe some of you have a vacuum cleaner in your home that can absorb the what we call it, the air. So here also the filtration can be used a vacuum filtration, which is connected to the vacuum machine that can absorb the air inside the flask. So the filtration can be running better. Of course, when you do the filtration, there must be a funnel here. This funnel is using also for filtration, but this funnel is normal funnel. Corong, yeah? This funnel is normal funnel. This normal funnel will not be used in filter flask. Yeah, this normal funnel is generally used for normal filtration. They are adding, for example, here filter paper, kertas saring, filter paper inside this funnel to filter normal thing. For example, if you want to filter sand from the water, yeah, if you want to filter the sand, pasir, in the water, you can use this funnel, yeah. With the filter paper, of course, you put the filter paper here and you pour the water with contain sand. What will happen? The water will goes through the filter paper, but the sand will be trapped in the filter paper. So this is a normal funnel, but for the filter flask, you are not using this funnel because this is vacuum filtration. So it is used generally for filter more difficult mixture. For example, if you want to filter the very small particle inside the water, yeah, sand is not small particle. Sand particle is bigger, so you can easily filter it. But if you have more smaller particle, which is difficult to filter with funnel, so if the particle is smaller, if you put into the funnel and filter paper, what will happen? The particle still can goes through the filter paper. So at that time, you need a more sensitive filter. That filter we call as a filter flags, and you're going to use different funnel. The funnel that you're going to use is this funnel. Yeah, as you can see here, this is called as a Buchner funnel. Buchner funnel is the funnel that is used for vacuum filtration. It is not for normal filtration, but it is vacuum filtration. So you need machine to filter the substance. So this one will be used together with filter flags. So this filter flag will be used together with the Buchner funnel. Someone microphone is on. Okay, good. So Buchner funnel will be used together with the filter flags. This is for vacuum filtration. Okay. So these two things are used for filtration. Another one is burette. Burette is the shape is like this. There is a tap here that can be open and close. Tap, yeah, kran. There is a tap here that you can you can squeeze it, open, close, open, close. It is used for what? It is accurately measuring or delivering liquid. If you want to pour a liquid, but it's a very accurate measure that you want to pour it. For example, if you want to pour 1 milliliter of liquid, yeah, 1 milliliter of liquid, then you can use this burette. So you will take the burette. The burette have a scale here. Ada angkanya ya, have a scale here, so you can know how many milliliter of the liquid that you deliver from the burette. So for example, if I open this tap, the liquid will goes down, and if you see the scale, if it's already 1 milliliter, then you close it. It means that you deliver 1 milliliter of liquid. So this burette is generally used for the accurate measure. Some of the experiment you need very accurate and small amount of substance. For example, 1 milliliter or 2 milliliter. It's a very small amount, and it must be accurate. If you have more a little bit, for example, it's not 1 milliliter, 1.5 milliliter, then it can change the result of your experiment. That's why sometimes you need a very accurate measuring equipment like this burette. Okay, so this burette, the function is like that. And another one, round bottom flask. According to the name, you understood that this is a round bottom. They have a bottom which is round here, and there is a neck here, neck and round bottom. Round bottom flask generally doesn't have a scale. There is no scale here. Tidak ada skalanya ya. And it's used for what? Running reaction. It's like the beaker also for running reaction. If you want to make a reaction, you can do it here. Heating chemical also can do here like a beaker. And mixing chemical also can do here. You can do it in a round bottom flask. And there is a difference between beaker and round bottom flask. In round bottom flask, the mixing will be easier. Yeah. In here, round bottom flask, if you want to mix the substance, it will be easier. The beaker is generally used for mixing the substance that only can be mixed slowly. You make it slowly, yeah? Because as you can see here, it is open here. If you mix it hardly, gently, what will happen? The liquid can be spilled out from the beaker. So that's why beaker is generally for mixing, which can be done slowly. But for round bottom flask, you can gently mix the substance. Why? Because the hole is a little bit small, because there is a neck here. After the round bottom, there is a neck, ya, lehernya ya. Neck, which is a little bit long here. So that's why it doesn't make a problem if you mix the liquid inside the round bottom flask gently. So it will not spill out because there is a neck here. So that's why it will be easier to mix the substance, liquid substance, by using round bottom flask other than beaker. And another thing is a graduated cylinder. This graduated cylinder is used for accurately measuring the volume of liquid. It looks like the burette, but the difference is graduated cylinders generally have more amount. In burette, maybe it's 1 milliliter, but in graduated cylinder, maybe it's not really accurate for 1 milliliter, but it will be accurate for 10 milliliter. So more amount of liquid if you need, then don't use burette, because if you burette, maybe you will wait a long time to deliver a liquid in a more amount. But if you are using graduated cylinder, it will be easier for you. Okay, so that's why this graduated cylinder have a scale also, a scale like the burette. Burette also have scale. Graduated cylinder also have a scale. So if you want to take 5 milliliter, for example, or 10 milliliter, then it's easier to use the graduated cylinder other than burette. Or burette, for example, you want to take 1 milliliter, then use burette. But graduated cylinder is more than 5. We have also some variety in size of the graduated cylinder. It has a very small graduated cylinder, which is maximum 10 milliliter. We have also a very big graduated cylinder which can take 500 milliliter liquid, for example. So the size is varies from the small to the big one. The next one is this flask. It looks like a filter flask, which is the difference is only in filter flask we have a vacuum canal like this, the hole here, but in this flask there is no vacuum canal. So this flask is called as a E flask, or this E stand for Erlenmeyer. Maybe you can write it in your book. It is Erlenmeyer. It's written Erlenmeyer. So Erlenmeyer flask. What it is used for, it's look like the round bottom flask and beaker. It's also for running the reaction. You can run the reaction here, heating the chemical, mixing the chemical, and it is also the same round bottom flask. For mixing the chemical here is easier from beaker, but of course it's not as easy as round bottom. Round bottom, as you can see, you can easily gently mix the substance, but in Erlenmeyer flask, again, you need to be slowly because the next is not really thin like the round bottom. In round bottom flask, the next is thin, but here it is not really thin, so you have to be careful. But it's easier than the beaker because the beaker there's no neck here. So Erlenmeyer is used generally for that one. We have also some variety of Erlenmeyer from the smaller one to the bigger one. And the next one is volumetric flask. Volumetric flasks look like the round bottom flasks, but the difference is it has a thinner neck. It has a thinner neck. Lehernya agak lebih tipis, and it is not really round bottom. Yeah, it's like the conical shape actually. Okay, and this volumetric flask is generally used to mix the chemicals like Erlenmeyer, like round bottom, like beaker. But this volumetric flask is generally more accurate scale. Yeah, volumetric flask, it has a scale. As you can see, there is a line here. Yeah, this line is show you that, for example, if it is 100 milliliter volumetric flask, it means that at this line, the number or the amount of substance is 100 milliliter. If it is 500 milliliter volumetric flask, if it's reached this line, it means that's a 500 milliliter flask. So it is not like the round bottom or beaker or E flask, which is not accurate. Volumetric flask is more accurate. So if you need to mix the substance which is accurate, how many milligram or how many milliliter you want to make the solution, larutan, then you will need this volumetric flask. Okay. Another thing, the most common one, this picture that I asked you in the pre-test this morning, it is test tube. And test tube, it is like the volumetric, Erlenmeyer, round bottom, and beaker. It is also using for mixing the substance, heating the chemical, which is running the reaction. But the difference is, test tube is smaller. It's very small. If you compare with volumetric, Erlenmeyer, round bottom, and beaker, test tube is very, very small. That's why it is called as a test. Why? Because for testing something, you just need some sample, right? If you want to test something, don't take all of them, but only take only small part of them. We call this one as a sample, yeah? So that's why test tube is very, very small, just for measuring the sample, yeah? If you want to test something, then you will take the sample by using this test tube. Okay? So not like volumetric for mixing, Erlenmeyer, round bottom, and beaker. test tube is mainly used for testing. So that's why it will take a smaller quantities than beaker and flask. Yeah, that's the difference. Okay, the next one is watch glass. Watch glass is generally taken for taking solid chemical, taking solid chemical from the label, from the container. If you want to use the solid particle or you want to balance, menimbang ya, the solid particle, you can use the watch glass. And watch glass also can be used as a cover for the beaker. For example, if you need to heat this beaker, if you want to heat this beaker, then you have to cover this beaker. This beaker doesn't have a cover. Round bottom flask, they have a cover here. Erlenmeyer also have a cover. Polymetric also have a cover, but beaker doesn't have a cover. That's why to cover the beaker, sometimes watch glass is used. Watch glass will be put in the upper part of the beaker to cover the beaker during the heating. Yeah. Another one is droplet or dropper pipette. Dropper pipette is like a medicine. Maybe if you have a small brother or a small sister, baby in your home, if the baby is sick, then how to give medicine to this baby? Generally, the medicine will be liquid, and mom will take dropper. Yeah, you drop it with some bulb. Generally, bulb dropper have bulb. Ya, ada apanya? Kayak semacam karetnya ya. That you can squeeze and release. That dropper is used for what? Generally, this dropper is using for dropping a small amount of liquid. And it's very small. It is only a drop, tetesan ya, untuk meneteskan. Drop a very small amount. It is not 1 milliliter. It's one drop. For example, if you need one drop of liquid, then you will use this dropper. So there is a valve here. Valve is like I told you, it can be squeezed. Ada apanya ya, kayak bannya itu ya, yang bisa dipencet. You can squeeze it if you want to take the liquid, and you can release it if you want to release the liquid. So droplet will have a valve in the head of this droplet. It is the same droplet or dropper pipette. We have also another pipette. It's called glass pipette. This glass pipette is also for using a very small amount of liquid. If it is droplet, is a drop of liquid. Glass pipette may be more than a drop, maybe 0.5 milliliter. So it's very, very small. It cannot be measured by using burette or round bottom flask or beaker or Erlenmeyer or graduated cylinder. You cannot measure 0.5 milliliter, which is very small. So to measure that 0.5 millimeter in accurate way, you have to use this glass pipette. Glass pipette also have a valve. Ya, di atasnya ini sebenarnya ada balonnya, ada valve-nya that you can squeeze and release. So that's why it is very important to take a very small amount of liquid. But you cannot see the valve here, but it must be a valve here and also a valve here. Two types of glass pipette. One of them is normal line like this, and one of them is have a round in the middle, but they have the same name. It is glass pipette. Okay, another one is glass stirring rod. It is just a rod ya, rod atau batangan rod which is made from glass. It is generally used for stirring chemical. If you need to stir it, you are not using spoon, of course. You are going to using the glass stirring rod. Buchner panel, I explained already. Polywash bottle, it is a bottle, normal bottle made from the plastic. But this polywash bottle, it is very not very hard. It is soft here in the plastic. The plastic is soft, so you can squeeze it. So after you squeeze it, the liquid will be coming from this channel. Yeah, the liquid will be coming from this channel. So if you have already watched boxing, yeah, boxer is generally a drink by using this polywash bottle. Yeah, they drink by squeezing. The water is coming out. Squeezing, water is coming out. So this polywash bottle is using for that one also. It's generally used for what? To add a chemical, generally solvent or water. You need to add some water, for example, in your experiment, then you use this polywash bottle. This storing glassware, we don't have the storing glassware in our lab. It's not very important, but it is for storing, ya, menyimpan, storing small amount of chemical. Okay, we don't have this one in our lab. This one, evaporating this is also important. It is like mangkok, ya, mangkok, ya. Evaporating this is used for what? To evaporate liquid. If you need evaporate liquid, then you put the liquid here and you heat it, then the liquid will evaporate. And another one, this is also the most important, stand and clamp, is we call it stand and clamp. This part is called as a stem. Sorry. This part is called as a stand untuk mendirikan, ya. And we have clamp, ya. Clamp here, this one is clamp. Clamp can be many type of clamp. Utility clamp, we have many type of clamp. We have the one which has three pinger clamp, so it's clamp like this, three pinger, or you have only two pinger like this, clamping like this, or any other type of clamp. But in our lab, we have only that two, three pinger or two pinger of clamp, and also we have iron ring here to maybe you need it for make the equipment stand still when doing the heating, for example. So that's why this ring clamp is also available, and this stand and clamp is used generally to setting the experiment. If you need to set the experiment, you don't have to use your hand. You can stick it or clamp it in this equipment. Okay, those are the things that you have to know. I'm going to add some of the things in the Google Classroom maybe later. Any other equipment that also important which is not here, but later on I'm going to share to you in the Google Classroom. For now, it is enough to know these things. Okay, after we finish the equipment, so lab stuff is finished. So we finished talking about the lab, introduction to the lab. So after that, we have to move on to another things. What are those another things? Another thing we call as a matter and its classification. Okay, I think you're familiar with this word, matter. We learned before matter. Do you remember the first lesson, I think, lesson number 1, we talked about this matter. What is matter? Do you remember?
Anything that equips space and have mass.
Yes, anything that has mass and volume or occupy the space, it's matter. For example, I gave you example wind. Wind is matter or not?
No.
No.
Wind is
No.
matter because wind is the moving
air.
Yeah, the air is the matter, but the wind is not the matter. I think you remember this example, right? We talked about this matter before. So today, in this section, we are going to see the classification of that matter. We are going to classify that matter into its classification. So in general, we have this topic. Still, the objective is the same, the nature of chemistry that we're going to learn. In general, this is the chart of the classification of matter. Matter can be classified into 2, pure substance and mixture. Zat murni dan campuran. Pure substance and mixture. Later on, pure substance can be divided into element and compound, unsur dan senyawa. Mixture can be divided into homogeneous mixture and heterogeneous mixture. But first, let's understand this, pure substance and mixture. Pure substance here, the example, when you see the example, water is a pure substance. Maybe you are going to confuse about this. How come, sir, water, how come it's become a pure substance? Because water is containing hydrogen and oxygen. Hydrogen mixed with oxygen to form a water. So it must be mixture, isn't it? Maybe you think like that. Because it has hydrogen and oxygen combined together to form the water. So it is a mixture, but actually it is not. Water is not a mixture. Water is a pure substance. Now we are going to see what is the difference between the mixture and the pure substance. Which kind of combination that we can call as a mixture, which type of a combination that cannot be a mixture, which is a pure substance. Okay? So we are going to see that one. To study about that one, to know the difference between pure substance and mixture, then you have to know this element, compound, and mixture itself. So we're going to see these three: element, compound, and mixture. What is element, what is compound, and what is mixture? We're going to come in for the first one, element. What is element? Element in Bahasa we call as a unsur. What is the important in element? The important thing in element is one kind of atom. Kind here important. Jenis, satu jenis atom. One kind of atom. So if it is an element, it consists of one kind of atom, not one atom. One and one kind are different. One is only one, but one kind, it can be more than one, but it is the same kind. Ya, it's different. Satu dengan satu jenis berbeda. So element is not one, but it is one kind of atom. So in chemistry, we have a table, we call it a periodic table, which consists of all the elements in the universe. As you can see this table here, you can see there is a lithium, there is iron, there is titanium, there is carbon. All the elements are put in the periodic table. So this periodic table consists of elements. For example, this is iron. So this iron is an element. This consists of iron atoms. There are so many iron atoms here. A very huge number of iron atoms inside this iron. But all the atoms will be one kind, one type. All of them are one type, which is iron atom. And another one, we have sulfur. Sulfur is also another element. It is an element also. Sulfur is the one that we use for soap, sabun sulfur, yeah, that generally used for medicine. If you have a itchy, gatal-gatal, then you use this sulfur soap. So this sulfur is also an element, right? And how about this picture? This picture is oxygen. As you can see here, oxygen is O2. It doesn't mean that it is a mixture. No, O2 consists of two oxygen, but these two oxygen are coming together and they are the same type. That's why it is also become element. And how about the compound? Compound is combination of two or more different elements joined together in a fixed proportion. The most important for compound is fixed proportion here. There must be a fixed proportion. Ada proporsi yang yang tepat. Yeah, the fixed proportion. For example, like I told you before, oxygen and hydrogen, there are two different elements, but they're combined together and the proportion are fixed. In water must be one oxygen, two hydrogen. One oxygen, two hydrogen. So that's why this water is not a mixture anymore. Although they are mixed, they're combined, but it is not a mixture. It is a compound. And compound belong to the pure substance. Kenapa? Karena proporsinya tepat ya, fix, not changing. Satu oksigen, dua hidrogen. So if the proportion are fixed, then it is not a mixture, but it is a compound. And also, compound have a unique set of chemical and physical properties. Properties of the compound is unique. So for example, oxygen has properties. Hydrogen have properties. Oxygen gas, hydrogen gas. Oxygen easily burn, hydrogen also easily burn. But when they come together, they become a water. Now they have different properties. Water is not easily burned. Water is not gas. Yeah? So when oxygen and oxygen combine together to form the water, they become a new properties. Dia punya sifat baru. New properties which is different from oxygen and hydrogen. If new properties is formed, then it is become a compound, then it is belong to the pure substance, not a mixture. The same thing for another example, NaCl, NaCl, 1Na and 1Cl, if it's coming together, it's become NaCl. It is also a compound. It consists of Na and Cl. Na itself is very dangerous. It can explode easily. Cl itself is also very dangerous. It is poisoning gas. But when Na and Cl coming together, they will become NaCl. As we know that NaCl is salt, garam. NaCl is the one that your mom used for cooking. NaCl is the one that you eat, yeah, or you put into your bakso. So it is not dangerous. But when you see NaCl, it consists of Na and Cl, which are very dangerous. So what happens when they come together? They become a compound. Then they will have a new properties which is different from the properties of Na and Cl. The properties of the origin, so it's different. So that's why if you combine two elements, they form a new properties and they form a fixed proportion, then this combination is called as compound. And this compound is not a mixture. This compound is called as a pure substance. Jadi kombinasi yang seperti ini bukan campuran, tapi senyawa. Senyawa itu masuknya ke zat murni, not campuran. So which one is the mixture? The mixture is also combination, but it is not chemically combined. For example, water and soil, air dan tanah, it's combined together to form a mixture that easily can be separated. And the chemical properties not changing. This is mixture. Air laut, water and salt are coming together to form salty water. This is also a mixture, but this one is not chemically mixed. They are easily to be separated. So this kind of mixture is called as the mixture itself. Okay, so we have to stop in here because we have 1 minute last. So after this, in the afternoon, we are going to Google Classroom. There will be an assignment that I will give to you. And next lesson, we are going to continue with this classification of matter. So we are still talking about this in the next lesson. For today, that's enough. See you in the afternoon in the Google Classroom. There will be assignment that will give to you. Thank you. See you in the afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.